Okay, yeah. So as I was just mentioning, the modules program is kind of designed for non-data science courses. So if you were just in the Data 8 or Data 100 sessions before, it's a very different program in the sense that the students that take this are not taking the course specifically to learn data science or generally don't even have any kind of statistics or programming background, and are definitely not to answer that question about is data 8 a prereq, it's definitely not a prereq for the modules. In fact, in most cases, most students will not have had data 8. And oftentimes, what we ultimately get at the end is an increased interest in courses like data 8 and data 100 from hopefully students that otherwise wouldn't have had access to it in the past. So I'm going to start sharing my screen, and then hopefully I can just show you some things.
নেক্সট টাইম থেকে এগুলো আনবে না। দিবাকর আছে।
Alec, are you presenting your screen?
Sorry about that. I was kicked out in order to be able to share my screen. So hopefully I can do that now. But let's go to screen. Okay, so here is hopefully, can you see my screen?
Yep, we're good. We're in. Awesome.
Awesome. So this is our early in development data science modules website. There's some information about it on here, but as I explained, it's a short explanation into data science to kind of give people an opportunity to use data science in backgrounds where they otherwise wouldn't have seen them. So feel free to check out this website. It's got some more information on us. And then also I wanted to show you our GitHub. The links to all of this are definitely posted in places, but we can post them again just to make sure. And here our GitHub is where all of our modules live. And by going through the GitHub, you can see all of the modules projects. There's quite a variety of them. As I mentioned a little bit earlier, hopefully you've had some kind of opportunity to go through Keely's talk and kind of see the breadth of courses that we touch. There's quite a few of them. Most are in the social science realm. We have a lot of courses like ethnic studies. We have courses like environmental economics and then history that I'll show you today. Just a really wide range of courses. And the structure is sort of one where in general professors approach us and try to get us to teach some concept of their course in a short exploration, meaning normally just a few lectures or maybe even just one in some cases. We kind of take over their class and present a supplementary data science thing to something they've already taught in the course. So I think it might be best explained if we just kind of show some of it and how it works. And then if people have questions, we can go along from there. As Eric was mentioning, and as Keely described in the talk yesterday, it is primarily student run. So I worked on this team for several semesters, and then I was a team lead for several more. But all of these modules are created by students, not students in the course, but students that are interested in data science education and contributing in the process. So we meet with professors, we kind of tailor to this to their course and try to bridge any kind of gap between the professor and the data science education program to try to really make it a cohesive experience where everyone can learn together. So the first thing, if everyone has access to this site, the 2020 demos site, hopefully if you were in the labs before, you do have access to it. We're here in the modules connectors demo labs. And the first thing I want to show you is this history 160 link. So if we can all click on that, hopefully we can get it. So it should redirect us to this Data Hub page. We have the Data Hub set up for this presentation for the workshop.data hub. And this should be a similar experience to what students would see themselves, but it should load. I'll give everyone a few moments to get there, and then hopefully if there's any issues, let us know in the chat. But hopefully in a few moments we can all be at the same place. So again, if we're there on the Google Sites data science education page, if you click on History 160, it should arrive here. If there's any kind of blank screens or anything, let us know and we'll try to diagnose that really quickly. But with that, hopefully everyone can see this.
Throw a thumbs up in the chat if you're in the History 160 notebook, or if you can find the History 160 notebook.
Okay, great. Seems like it's working. So again, this is a very similar experience to what the students would feel. There's no like setup or anything, and I think that's one of our main reasons for focusing on the Jupyter environment so much, just that there's no setup. These students have had no background in programming or anything, and so we just kind of give them this link, and then suddenly they are in an environment where they can program. So we begin by just kind of, because there is no requirement of any kind of programming or any kind of data science prerequisites, what we can do at the beginning of these modules, what we do is often have this kind of basic introduction to Python that is faster than would be required to actually learn it comprehensively, but something that can allow students to get through the module. And then in the case where students are exceptionally excited, which we hope that they are, we give them links to more resources that they can actually go on. If you're having trouble logging into it, I see there's a few people that are, then please try maybe in a different browser, or trying the link again, or refreshing the page. Hopefully there's someone that can help diagnose those issues in the chat. But so how we actually, I guess, again, how we introduce this to professors is generally we have a system where we reach out to professors that might be interested in these courses, and then we kind of sit down together and discuss a topic that they could have contributed. They could have Python and some kind of module contribute to their course, and then we discuss that with the students that are running the team, and everything comes together from there. So for instance, this history class, History 160, is specifically a European economic history class. So it was taught by Professor Andrej Milevich, and he came to us and asked us to help teach the demographic change section of his course by creating some plots in Python. So again, what we're doing here is a quick introduction to Python so that students can get there. And I'll go through the introduction just a little bit so we can see how students would see it. So once we are all loaded in here, we teach students how to use the basic Jupyter environment. Shift Enter at the same time will run a cell. And then once you do that, you will be able to see some things. So now here we have a basic exercise that we can show to students. So if we have 3 times the product of 3 to the power of 6, and then we subtract 167, we should get 2020, current year. Occasionally at this point, we would have students try various things. They'll put in something there, and then they'll get scared by a syntax error. For this purpose, we generally have lots of people walking around, trying to ensure that people don't fall behind. It's sometimes intimidating the first time you see code on screen, and so we try to take away this intimidating aspect, first by using Jupyter Hub, and second by just kind of going through this all together and encouraging students to ask questions as they.
Hey, Alex, somebody raised their hand in the participants.
Yes. How do
Mikari?
Yes. Feel free to ask your question. Oh, I see the hand. Yeah.
Yeah, I'm good now. I'm good. Thank you.
Okay.
Okay, thank you. So, and then we walk through these examples here. Here we teach students how to assign various variables, and then we can go through an exercise to print hello world on a lot of the things that you'll see in the very beginning of either Data 8 or any kind of programming course. We try to give a very quick crash course on this so that we can actually do things. We show introductory functions. So we can add a and b times c. So we could do return a plus b times c. And then we would get the result of that. A lot of this is going to be live coding by the students that are presenting in the course. And then we just go through these exercises, we print a few things, teach some introductory data structures. But essentially, once we get through these things, we actually get to the meat of what we want to see. And this is where I believe the modules are particularly impactful on the course. So as I mentioned, this is a course on European economic history. This course specifically talks about a wide range of topics, but in this section, they're talking about changing demographics and how demographics change over time in various different countries, and this kind of natural progression that tends to occur that allows for the curve of the total population. So what Professor Milevich did in this course is he presented this exact picture in an earlier lecture, and then he wanted us as the modules team to create an environment in which the students could arrive at very similar graphs on their own and see that the real data actually does match up this expected result of birth rates and death rates kind of decreasing at a staggered rate here. So we have these multiple different stages of the demographic transition, where first we have high birth and high death rates. The death rates fall down first, followed by birth rates that fall and result in this kind of curve of total population. And so what this allows us to do is specifically to take a look at data from real countries and to try to create these graphs on our own. So in this case, first we show some introductory plotting techniques that could be used. So we do these kind of introductory things so that individuals can actually see how we're going to arrive at various things. And then so this is, for example, just a simple graph. We're showing how the plotting mechanism works in Python using matplotlib. We do that, and we introduce how we can load data using pandas. We have a data frame of clean data that we have already cleaned for students. And then we show the frame here to show some of the results. And then we kind of go through this and show how we can use matplotlib to actually use our data frame of data that we have here, where we have population, live births, deaths, and then we can use it to create what we actually want. So if we take just the year values and the population values, and then we're just going to plot one against the other, and then we should see a plot. And then we show that this is ultimately not what we want to show for students. And so we notice that there's actually some difficulties in the cleaning of the data, how we actually run the data. And then we ultimately show that there's actually an issue with how we read in the data. And we should be using them as, not as strings, but as integers. And that's the result of this kind of mess on the y-axis here. So once we read in the data in a different way, we see a slightly different result. So I see there's some questions on why we're using pandas and why we're introducing some of the topics that we haven't necessarily used. So yeah, I introduced the for loop concept and how to use a function. Again, those are primarily to kind of give students some kind of level of comfort with the environment that we're using, and hopefully allow students to use some of these things on their own if they want to use it in the future. So these notebooks should work as entirely standalone. And one of the things I like about it is that you can actually access this link that you have in front of you. It's your own personal notebook. So if you go and access this and you make some kind of changes, you can continue working on this notebook in the future. So we want to be able to give students the resources necessary to use this notebook in their own like data exploration if they want, even if we're not necessarily using it. As far as the choice to use pandas rather than the data science package, often this is just kind of a developer choice. In this case, the developers that worked on this course were not as familiar with the data science package and were much more comfortable with pandas. So we chose to do it mostly in pandas. As I mentioned, it's all the students that are putting in the work to try to put it together. And overall, we don't really have a preference towards one or the other in the sense of these modules, because the idea is, again, to sort of introduce it and to have it all contained in one module. So as long as students are able to kind of understand how these plots are coming together by the end of the course, we think that the module is, at least on some level, successful. So here we have been able to plot a simple graph of the population of Sweden. It seems to be increasing and similar to what we would expect of its overall total population from 1750 on. And now we get into a little bit more tricky things to show how we can actually arrive at the birth and death rates in this course, and I guess more generally are generally expressed as in terms of every 1,000 people. So like a birth rate of 0.01 would be one birth per every 1,000 people. So what it would be one birth per every 1,000 people every year. So here we have a calculation of the birth rates and the death rates by multiplying our live births by 1,000 and dividing by the overall population. Same thing with the death rates. And then we just kind of plot it, and we give students the ability to change any of these individual aspects. We encourage them to play around with the code. So I can change that to red instead of yellow. All kinds of different things that students can do to try to create these plots on their own. Because again, the entire purpose of this module is to have students be able to not only see the data, but feel like they are creating these plots somehow on their own. Because if we scroll back up here, we can show this picture, and it's definitely very pretty and illustrates the concept. But the whole purpose of the module is to kind of give the students the ability to recreate this themselves and to feel like they are understanding of it more deeply because they're creating the plots themselves. So the developers, we are creating this with no real connection to the course other than the fact that we have discussed with the professors on how they want to implement it. We generally meet with the professor probably 2 or 3 times before this, and the professor gives us material beforehand, and then ultimately we show them a couple of drafts of the notebook, and then either we give them the completed notebook and the professor can present it on their own, or the professor can request that we come in and do the presentation for them. So here the professor did not really require analysis of the graphs for our presentation, but they used the notebook for further analysis. And so one of the things we did during the presentation is we kind of looked at the plot and we discussed why certain things happened the way that they did. So why is there a massive spike of deaths here in 1770? I believe that corresponds to a large outbreak of smallpox in Sweden and around the world. And so we kind of do this kind of analysis and discussion of what's going on. In this course in particular, there wasn't a programming component that students were then graded on. But the key thing that we wanted to do here, and ultimately we achieved with this graph on its own, is show that we have a decline in death rates and a decline in birth rates, but the decline in birth rates lags behind the decline in death rates, creating this kind of plot that we saw up here using real data and real analysis that the students can actually do themselves. So that was the narrative that Professor Milevich wanted us to arrive at, to sort of give students the ability to recreate the image that he had. In other courses that we've done, we've had both less direction and more direction depending on what the professor wanted. Sometimes the professor wanted something very specific or others more of an abstract tool. In the module that I'll show you later, the tool that we created was really just for students to use, but wasn't really a part of necessarily the teaching curriculum. But I think that this example is one of the core representations of how we did the modules program, in that there's something somewhat specific that the professor wanted us to achieve, and then we do that pretty much to the specifications. But in other courses, we have had sort of thing where a general concept is something that the professor wants to display, and then the developers have their own kind of approach that they're able to use and see. So hopefully that answers on how the narrative comes together. Yeah, so I can tell a little bit about the development process and then continue going here. So the development process, as I mentioned, we have these student teams that are comprised as part of this division of data science education program. Most of them are volunteers. Most of them come from computer science backgrounds or data science backgrounds and want to be involved in the curriculum development program. Students in the course have no intention of taking a data science course. Here they're just taking either a history course or a economics course, and they are taking the course as such. The professor has some idea of some topic they want to discuss, and they contact either Eric or Keely, or Keely and Eric contact them if they think their course could be a good fit. And we kind of discuss how we can integrate the module there. And then the modules team works to develop kind of a plan for how the course is taught. But it's a very open and very malleable setup process for the module. Essentially, the modules team is just a set of students that are willing to create a presentation and kind of brainstorm how that actually comes together with the professor. So really, the entire purpose is only to show some kind of data science aspect of the course, and there's no set structure that it has to follow necessarily. So hopefully that somehow explains a little bit of how that actually comes together. And then, in addition to what we see with Sweden, we also decided to show students a couple of other countries here. So we can do the same thing for Chile. Here we discuss a couple of perhaps difficulties with data science and having data that's not perfectly clean. A lot of the data that we got for this was in different formats. For instance, the population may have been expressed in hundreds of thousands or millions in one case, and then in a different version in another. And that's all things that data scientists and students, if they would like to pursue this a little bit further, would have to deal with on their own. And so we try to discuss that with students and show them how that would come together. Ultimately, we were able to arrive at a very similar plot for birth and death rate of Chile. At this point, we would stop, and the professor interjected with some kind of analysis that they were discussing. So in this case, I'm not sure why there's a large drop in deaths here. I believe this actually corresponds to the Chilean Civil War. So perhaps there were issues with data collection and reliability of government supplied data. These are all things that we try to discuss in the course, give it perhaps a human context and ethics understanding of like where we're getting this data, how we're using this data, and why we're using this data, and ultimately come together for a deeper understanding of what's going on. So in the case of this course, what we did was we showed how this worked for Sweden and Chile, and then we asked students to get it for Russia on their own. And so the version that you're looking at is actually the completed version, but in this case, we actually left a few blanks here that would allow them to take a look at this and create the plot entirely on their own. So here we have Russia. A similar trend seems to happen, and then we actually see that the inverse happened here, that the death rates appear to rise again at the end of the Soviet Union, and we can do the same for Mauritius. And we go through these and we take a look, and ultimately the end goal is to have students be able to recreate data that they have seen in their course. This one in particular is a little bit more advanced. Again, we're trying to incorporate some more advanced topics because students may come from different backgrounds. So here we are creating 2 data frames and then actually merging them, because in order to see the population, and one of our data sets only has data from 1750 onwards, and the other team that has data from before. So we can actually do something like this, and we would do some kind of live demo presentation here, where we're here looking at, let's see, so we can look at the population of England and Wales here, and we can show how we get that population. We show them how we can add a title, population of England and Wales, should be reversed here, but ultimately we show various concepts like this and then allow them to arrive at things on their own. And generally there's just quite a bit of discussion that goes on during the course. Lots of students have questions. Students will think that they broke everything when they have a syntax error. We try to eliminate that fear. Doesn't always work, but the goal is to try to get students to be more comfortable. And that's ultimately what ends up happening with these. And I always like to stay behind at the end of the module and discuss with the professor on what they thought. And in courses like this is actually the second time we ran the module for Professor Milevich here. We ran it for his class this semester before, and he liked what we developed, but we weren't ultimately able to use it in his course that semester due to, I believe, wildfires in Berkeley that semester. So he wanted us to come back and work on it again for the next semester. And we believe that the extra time in iterations of the course allowed for it to improve. It's something that's actually become more and more common, that a lot of the times the professors don't just do it one time in the course, they actually come back and try to get us to do it for a second time or a third time. There are several courses that we've done, I believe, 4 or 5 times. And so ultimately the goal is to just kind of introduce them to some of these concepts. And then at the end, we have a survey that they take, trying to gauge their interest in the concept. And so I think one of the most interesting aspects, and some of you are touching this in the comments here, just the fact that there are different backgrounds of many students. So in this case, the history major does not require any kind of programming component. The economics major requires very, very little. So most of these students, at least unless they had their own initiative to take a computer science course, probably haven't had any kind of background, but some students have. And so we want to try to make it as unintimidating for some, but also keep the interest of others. And it's very difficult in some way to kind of have this kind of balance. And that is something that we're still struggling with and still trying to perfect. But in the end, after I stay behind and discuss at the end, there's always students that come up, ask questions. They've kind of manipulated one of the plots that I did on the screen, and then they try to ask some questions about, what if I did this? And then it seems to hook the interest of at least a few students every single time. And that's ultimately our goal. And then at the end, we give a pitch for Data 8 and some of the other data science courses to try to kind of throw them into the pipeline, or at least expose them to this pipeline there. And so there's a lot of that. And then as far as how much professors enjoy this kind of material, they are often not responding to any kind of student demand, but I think it's mostly because they want to integrate something like this in their classroom. So for this module in particular, we see that Professor Milevich had this concept that he wanted to teach, but he felt that it would be better understood if students were able to view it with real data. He doesn't personally, or didn't at that point, have any programming background, or a strong programming background, I believe. And so perhaps he didn't feel comfortable presenting it on his own, And so there's a lot of different professors that come from a lot of different backgrounds that want to present some kind of data science in their course. So it's mostly professor driven. It's not really that students are asking for these modules in their courses, although increasingly, as we have touched more and more students, it seems that students do enjoy having the modules, at least from the survey results that we are getting, and that students would like it more in their courses. So in the case of this module, again, we're able to just kind of supplement something that was already taught in the course. In this case, we came in for a 1.5 hour lecture into this History 160 class and just kind of showed some of the topics that we discussed. And then in future classes, Professor Milevich relied on some of these plots to kind of hammer down some kind of concepts and discuss what is going on in the plots more thoroughly. As far as annoying or frightening students, that doesn't seem to be what we are getting from our survey results, although I guess it is possible that some students are frightened or annoyed by the material. We do think that it tends to be something that is a good supplement to the course in the sense that this is kind of a break from the standard lecture that they had and kind of a deeper dive that doesn't feel as though it requires you to do a lot, but if you want to actually go deeper and try to understand it deeper, it allows you to do that. So the way that we construct these modules is that it's mostly very guided, and that if you just follow the lecturer, you'll be able to actually have the result that you want. Whereas it also allows you to have some kind of approach where you can take matters into your own hands and kind of develop things there. So hopefully that answers some of your questions on this History 160 module. Sorry, I'm scrolling back and forth, but that's kind of an overview of how the history module specifically is run and how we created the module. We created it with a team of 4 in this case, it was 3, and we then gave it to the professor. He looked it over, he gave it back to us with some of his comments and changes, and then we implemented it and then came into his lecture and did it live for his students. One of the other modules I want to showcase, well, first I'll take a look at some questions and see if there's anything there. But from what I've been seeing is that students do tend to enjoy having these modules, at least in some courses. In courses like this specifically, where it's not a particularly invasive thing, where it's just a one-time exploration, it doesn't require too much of their time, and if it does spark an interest, then we think it's ultimately a good thing. But sure, probably a lot of the students just kind of brush it off and go on with the rest of the course. But the idea and the goal is that some students that perhaps otherwise wouldn't have been too exposed to it are getting this kind of data science education that they want. So yes, generally the students will have laptops with them in most of these courses. They can follow along without them, but yeah, we recommend laptops for this kind of exercise. And in most courses, at least in large lecture halls, students do tend to have laptops. At least I know the university also can provide them for students that may need them either on loan from the library or some kind of long-term program. But with that, I want to go on to the EAP 147 module. It's the second link here on the Google Sites page. And so when we click that, it should redirect us to this page. Now, this module is very, very different in the sense that it's not the same structure. And as we've continued to do more and more modules, the structure of modules and their adaptability has begun to change. So I saw a lot of questions that are very concerned about like the exact structure of how it works. And the reason I wasn't able to give a very concrete answer is because it's very much up to the professor and whatever the professor wants. And we'll work with the professor to try to create something. It's generally a project that takes a semester. We have developers that do about 6 to 10 hours of work a week, but it's developed over the course of the semester, and somewhere midway through the semester is generally where we would present these to the class. But some context for this class that is EAP 147 is specifically the electricity strategy game that they play throughout the course. Now, it's something that they've played for years. It's a game that was developed by the Haas School of Business, and it's supposed to model the electricity markets of California, and specifically give a better understanding of the California energy crisis about 20 years ago. And the idea behind this game is to set up different teams in which each team has about 2 to 4 different students in it, and they're all assigned a portfolio of electric companies. So in this case, we have the names Bayviews, Beachfront, Big Coal, Big Gas, East Bay, Fossil Light, Old Timers. And so these are portfolios, and in these portfolios, there's a variety of different plants that you can control. You can turn them on, you can shut them off if you'd like, you can do all kinds of different things, and then ultimately what comes together is you give some kind of bid of the price of electricity for that. And based on the bid and the bid of all of the other participants in the game, we create a market price, and then there is some set market demand that is unknown to students before the beginning of the round, but there's some predictions that they have. But then given that market demand, we generate a market price, and because of that, we're able to see that based on the bids that were given by these teams, some electricity is purchased from some and not from others, and then some kind of profit is made. So it's a game that happens over the course of many, many weeks. That was a very quick description, so perhaps it's not as in-depth as would be necessary to understand, but it's a game that takes place over quite a long time, and students traditionally would participate in it by giving their list of bids, and then next week getting some results, and then discussing with their team and getting a new list of bids again. And so the reason that we made a module for this course was to present a new way to kind of look at the data that they're getting and a new way to understand the game that they're seeing. So a graph that I want to show first, before I go through the rest, is kind of this analysis of the market. So here we have on the x-axis, we have the capacity of individual plants. On the y-axis, we have the price that is given by the bids that the bids that are given by these individual plants. And so, and the colors are the portfolios to which these plants are actually a part of. And so when we have these plants, we line them up by their bid price. And based on some demands, in this case, we have a demand of 10,000. And so with a demand of 10,000, we see that a price of $38 is set. So this visualization is something that, it would be something that they discussed in the course before. That's the structure of the marginal cost, and then how the price would be determined from that. This is, again, an economics course. We came in about 2/3 of the way through the course. So this is a plot that should be very familiar to students in that case. And then what we can do once we arrive at this plot, so we start with all of the same introduction that we had before about introducing Python to students that might not have had it before. And ultimately, we begin with this plot, really. And so when we get to this plot, that's something that they should be familiar with and understand. And then from there, we can add various components, such as adding a carbon price. And then what's really interesting, I think, is that they can have their portfolio. So for instance, we are the owners of the portfolio Bayviews, and they can use these interactive things that we made to actually interact with their portfolio and see what their profit would be. So in this case, if we are Big Gas, the price was $38.06, but all of our plants actually bid above that. So none of the plants would actually be operating, and there wouldn't be any profit made by this Big Gas corporation. Whereas if we go to someone like, not Beachfront, but let's say Fossil Light, in this case, this plant here has no price to actually produce, but they are able to sell all of theirs at the market price of $38.06. So this entire area is determined as a profit. And so ultimately, we can use this to really see how our plants are doing over the course of the game. And the entire idea is that this is supposed to be a resource for students that otherwise wouldn't really have a way to visualize how the plants are doing. So if we continue to go on here, we can do the same thing with the marginal cost rather than the bids that we have. And specifically, this will only show the plots that are profitable and the plots that will, the plants that will be running. And then we create this function where we can show the profit based on the data that we were given. So beachfront, as we saw earlier, and big gas, they're not actually going to operate any of their plants. And they're not actually going to have to manufacture anything, but because of that, they're not going to have any profit. Whereas as we saw fossil light up here, they're going to make quite a lot of profit because they're selling at this price of 38.06, but can produce at this profit. So again, the purpose of this module, at least in this notebook, this class had actually a variety of notebooks that we gave to the professor, and the professor was able to use their team of GSIs to edit it as well. But this course was ultimately developed to not have much interaction with the functions that we actually made, or much editing of the functions that we made. These functions were specifically to allow students to visualize things. So in this particular notebook, the students aren't interacting with the code, or they don't need to be interacting with the code. What we heard as feedback from professors at the end, or from professor at the end, was that there were several groups of students that did actually choose to go further and did try to manipulate our functions a little bit to try to give better predictions for the future. So because the game is all about planning out each round, and at least the game itself is worth a pretty substantial section of the grade itself. So this is all, yes, as mentioned there, these notebooks are not graded. They're not part of the course grade. They are a supplement to the instruction that is already being given. But in this case, the electricity strategy game is something that composes 6 to 7 weeks, I believe, of the course, and it is a major component of the grade. And so the electricity strategy game, as I mentioned, is based on the decisions that students are making. The decisions are making about their bids and the outcomes that are occurring as a result. And so we think that with a visualization, it allows students to have a better approach to understanding what they're doing. For instance, if I were to make a bid of 42 for this plant, perhaps it wouldn't be as easy to understand why I wasn't making money. Whereas if I am able to see all of the plants lined up here, I could see why if I'm a plant up here, I'm not making money. Whereas if this plant were to, instead of making their bid around 50, make their bid lower, they would produce energy and then be included in this curve here. So is there any advantage to having the code in the foreground versus using a Jupyter book? So I think the advantage of using the Jupyter notebook is, as we discussed before, just the easy accessibility of it. And so we prefer to have a Jupyter notebook because we have the data hub that all students enrolled have access to. They can come back to this if they make some kind of adjustments in the plots. So we think that Jupyter notebooks in general tend to be a pretty unintimidating way. And generally, we just tell students that are afraid of the code, we can tell them to kind of ignore the code that's in some of these functions. And then for students that aren't afraid of the code or would like to learn more, they have the option of editing the code right there, and they'll be able to come back to it. So in the context of this game, we actually saw that students did utilize it a little bit. They would be able to make more informed decisions according to the professor on how the game progressed. But in the same vein, there were also some students that didn't really find an interest in the programming portion, and kind of ignored the notebooks altogether. And in the context of this game, that was perfectly acceptable because that was the traditional way that the game was actually run. But at the end of this, we did notice that some members of the class did take an initiative and did try to learn a bit more. So I think one thing that this kind of shows about the modules program is really emphasizes its use as a supplement, and a supplement to courses that don't need to be redesigned around a data science curriculum. So I'm not sure how long the electricity strategy game has been taught in this course, but I know for a fact that it predates the division of data science by quite a bit. And so the fact that this game that has existed before the division of data science at Berkeley even existed, before we had these data science courses, I think to me shows that the usefulness of a supplement to existing courses is a good transition to a data science education program, at least in our experience here. So the ability of students to expose themselves to data science in places where traditionally they wouldn't get that exposure seems to have some value in this case. Do you find that having the code makes the data feel more concrete to students versus something someone created at some time? I do in some degree, and I also think that the student presentation is also something that's very impactful. So this past semester, I did not get to present this notebook, but last semester, I believe, maybe it was 2 semesters ago now, but when we first created these notebooks, we actually went to the class and presented it for the first time. And I think it gave students a greater connection because we, the developers who actually made this tool for them, were showing them how to use it. And the fact that we were all students, and in fact, I knew many of the students in that course, I had friends that were taking the course, made it seem less of a daunting thing, I believe, that, look, their peers are creating this tool that they can use in this game, and then it can have some kind of useful outcome for them. So I think having like the student run thing there and having the students write the code and present it to other students was ultimately a very impactful thing to how the notebooks were perceived. But just kind of, again, as an overview of this module, they had this game, and then we developed a supplementary tool, which was very voluntary, but we noticed that a lot of students did end up finding an interest in it. And we're not entirely sure how many students ended up becoming data science majors because of this. Maybe it was none, but we do think that there was some kind of pipeline to interest in data science from a perhaps non-traditional pathway. An environmental economics class is not, I guess, traditionally where you would learn to program. So I think the ability of students to expose themselves to programming, if they were interested or not intimidated, and to try to present it in a non-intimidating way, was something that was very valuable to the ability of students to enter that data science pipeline. So with that, I kind of want to just leave it up to some questions on perhaps the program more generally. I know that the game might seem more complicated than I'm able to describe in a short analysis, but I assure you that it wasn't as complicated to students because the students were, again, part of this class for the entire semester and very familiar with the game. And so the idea is, again, to introduce these supplementary materials to allow them to use it better, perhaps. So in terms of, again, how developers actually do it, we require different developer skills for different modules. So Data 8 is where I began. So I was able to work on some modules from Data 8. I believe this module required some background from Data 100, and as a result, the developers were older students that had more experience. Most of them, I think, had already developed for some module in the past. So we have varying levels of commitment. And one of the things about the modules program as well is I think that the ability to join the curriculum development team after just one semester of taking a data science course For people that are interested in data science, it definitely allows for an expansion of that interest. And then we have different Python environments per connector module if one course requires a specific package. So we don't have different environments per se. We have just this data hub environment, but we do have the ability to obviously load in any package here and use varying versions of it. And in some cases, we do have different hubs created for, and those can serve as different environments. So we have this hub created specifically for this workshop, but most of the users are using this datahub.berkeley.edu, which is a single hub that has a single environment. But there are, I guess, some specialty cases where things are used. And then yeah, as Eric is explaining there. The connector courses are courses that are much more tied to Data 8 than the modules. So as you might have noticed in my presentation here, the fact that we're not using the data science package and in the first module, and the fact that we're relying a lot on pandas, this isn't necessarily things that we would see in Data 8. And so the modules program does exist sort of independently of Data 8 in that sense, whereas the connectors are very much intended to be taken either along with or after Data 8. That doesn't apply here. This is again an independent thing in that sense. But yeah, I think a lot of the concerns naturally is like how the professors interact with students. And I think a lot of that does come from initiatives either taken by the professor or the students. The best modules that we've had were the ones that the professor had like pretty clear directions or a pretty clear idea of what they wanted to do. But as long as the professor is willing to be engaged, we've definitely noticed a lot of success. A lot of the professors that I worked with on modules gave a lot of freedom for myself and other developers to kind of put together the material that we thought would be best. But this back and forth where we send the draft notebooks to the professor writes comments and comes back, is definitely something that we found works pretty well and ultimately can culminate in a good experience. Again, as I mentioned before, I think a testament to the success of some of these modules is the fact that the professors are asking us to return. So, I mean, might not be entirely true, but I do think that if a module was not a positive contribution to the course, I don't think that the professor would choose to continue going on for it. But this game has now been taught for 2 semesters of this course now using our module, and I believe they intend to do it again in the future. The History 160 module, some of the other modules. We seem to have a lot of interest in renewing modules that have been done in the past. So with that, I can stay behind a little bit here and answer some more questions if they're left over, but that's the end of my time. I did do a module in French. It was a class on French culture, and the module was about analyzing the gentrification of Paris. So we did some mapping there. So yeah, we have quite a variety of different modules, not in any particular field, and I think that's what makes them so adaptable and so useful. Thanks. Yeah, thanks so much, everyone. Yeah, as I said, any further questions, feel free to contact any of us, and we'll be happy to help and tell you more about the modules program.